Hi, this chapter we talk about motions, Newton's law of motions. We have been talking about accelerations, with speed changes or velocity changes. But now the question is, what causes the velocity changes? Well, a great scientist, Sir Isaac Newton, has the answers. And in terms of Newton's three laws of motion, okay, and how forces interact with the acceleration. So if I ask you a question, what causes the speed to change? What get things to move? Then answer is the force. Okay, and then you will ask what is actually the force? The force is actually interaction between object. The force will make object change its speed. So then Newton has three laws of motion, and which is very compatible or with agree with your normal experience or your daily experience. So Newton's first law says, okay, with no outside force, the object will never move. All right, first law, and if there's no outside force, and the object will just, if it's already moving, it will never stop, keep going. So another way of saying this, first law, remember, listen, and the object at rest or in motion will stay that way unless being acted upon by a force. And use your own words, well, if you don't bother the object, it will not move. So that's Newton's first law, which means if there's no force, the object just either remain at rest or stay in the straight line unless they're acted upon by a force. So this is a formal statement of Newton's first law. Actually, probably is the original statement if you dig up the old ancient document. Every object remain at rest or in a uniform straight line motion unless being acted upon by an unbalanced force. Okay, in fact, remember the word unbalanced. There could be multiple forces, but as long as the overall force is zero, then the object will either remain at rest or uniformly straight line motion. Okay, that's Newton's first law. So that's, or to remember this, just simplify, okay? It's like, if you don't bother object, it will just keep the way it is. Either stay at rest or keep going in a straight line. So now, let's say something more interesting. Then that's what Newton's second law says. Newton's second law says, if there is a force, then there will be an acceleration. All right, there will be acceleration. So there will be acceleration, which means it will change its speed. Or if this force is in the opposite direction of the velocity, and it will slow the object down. It will change. So in this case, the force, there was a gravitational force component along this direction, so it will speed up. So force caused acceleration. And in this case, the gravitational force is against the velocity, so it will slow down. Of course, the picture sort of should put the finger the other way, the force goes that way. And of course, back to the third law, back to the first law, if there's no force, and of course, it will stay either at rest or in a straight line. You get a question, say in your own words, what's Newton's first law? And you will answer object at rest or in straight line motion will stay the way they are unless being acted upon by a force. Or another way of saying it, Newton's first law, if you don't apply any force, the object stay at rest or in straight line motion. Okay, the second law, if I ask you to say, what's the second law? Second law say, well, acceleration will be proportional to the force, okay, and also is inversely proportional to the mass. So for an object as mass, its acceleration depends on two factors. One, the force applied to it. to the mass. So the force is proportional to it. The mass is inversely proportional to acceleration. All right, so force and accelerations and mass, how they relate to each other? Well, through Newton's laws. Okay, first law, you already remember. Now, second law. Okay, so in the mathematical form, the acceleration of an object is directly proportional to the net force acting upon it, and it is inversely proportional to the mass of the object. Okay, I got a couple of videos, and if you get the file, you can watch it. But here is it. Normally, I would prefer this form. This is, if you want to do the calculation, acceleration, okay, and directly equal to force, and divided by the mass. So then, and sometimes, as you can see some posters, and they write in this form. So those of you who are still remember the mass, so if you put acceleration, you divide the mass to the other side, is exactly going to this form. Acceleration equals force divided by mass. So giving an example. So here example. What is acceleration of a 1,000 kilogram car if 5,000 Newton force was applied to it? So we directly apply this Newton's second law equation, and mathematically you just multiply 5,000 kg times mass. So that's actually Newton's times 5,000 Newton. Newton is actually in this units, and divided by 1,000, that's the mass. So then you will have 5 meters per second squared. So the force is in units of newtons. Okay, and how much is the Newton? It's like a something like a pencil, no, a couple of pencils weight, that feels like a Newton. So if 5,000 Newton is on a 1 kilogram, it will be accelerating. So suppose this object, a car, is floating in the air or in the space. If you have 5,000 Newton, and then it will be applied to it, and then it will, what is its acceleration? And it will be 5 meters per second squared. So force are in this units, so that's its dimension, but actually just remember it is called newtons. That's in the SI units. We talk about that's international units. The force is in the units of newtons. So if you want to calculate acceleration, you give force in newtons and divide by mass, and then you get acceleration. To connect to the common sense, here are some examples. So if you have same force, okay, if you apply to a smaller object, okay, so same force, smaller object, the mass is small, you have a smaller division, smaller divider, so therefore have a larger acceleration. Okay, if same force. Well, if you have a large mass, okay, same force, and you have a small acceleration, that's fit to your normal experience. Therefore, so if you have a small tennis ball, okay, put force, it will accelerate, say, 20 meters per second squared. But if you have same force, you have a big car, big mass, you divide by big mass, and then it will also accelerate, but small. But then this is again Newton's second law, like this. Force, many people write like this: F equal ma. So force equals mass times acceleration. I would rather just go this form. Okay, acceleration equals force divided by mass. So that's exactly fit to the original statement. The acceleration of an object is directly proportional to the net force acting upon it, and inversely proportional. Whenever you say inversely proportional, which means dividing, to the mass of the object. So this is really simple, and mathematically we can solve some problems, but simple but very important. We can solve some problems and questions involving Newton's second law. Once again, Newton's second law simply says the acceleration is caused by the force and is directly proportional to force, which means the larger force you push and the larger the acceleration. And also the other ingredient of the Newton's second law is the mass. So same force, the larger mass has less acceleration, smaller mass, higher acceleration, as is illustrated over here. Exercises in the handout, exercise 5, and I'm not going to write here, but you just listen. I'll give you some hint. And in your own words, what is Newton's first law? What does that mean? And it means that the first law says an object remains at rest or in a straight line motion if there is no force acted upon this object. And what does that mean? That it matches very well with your normal experience. If something is at rest, if you don't bother it with the force, it will stay there. And also the other part is interesting is if the object is already in straight line motion, and it will be continue moving straight. All right. So if you want to use your own words to talk about it, and if so something, I would say the object is just to stay the way it is, either just at rest or in a straight line motion if you leave it alone, which means that's Newton's first law. And second law, so actually these two laws are connected. And Newton's second law says the rate of the acceleration is directly proportional to the force acted upon on an object, and it is inversely proportional to the mass. Okay, now the two part that's important, the force and the mass, that both affect the acceleration of an object. So the force is directly proportional to it, and so which means the stronger the force, the stronger the acceleration, or speed up faster. Or the mass is inversely proportional to the acceleration, which means if you have the same force, well, the bigger mass will resist the change in velocity stronger. So the bigger the mass, the harder to accelerate. So, but in your own words, well, you will say something like, if you push stronger, the object will speed up faster, and if you have a heavier object or bigger object, then it will resist change more. Okay, or you can use your own words. I know you know what to say. So number 3, I will work out this in. So this is the mathematical form. So a force of 10 newtons in strength applied to an object of 3 kilograms. What will be the object's acceleration? So this is simply directly applying Newton's second law. Okay, A equals the force divided by the mass. So 10 divided by 3. So that's simply a division of these two. And of course, if I give you 6 kilograms, the acceleration will be less. Okay, 9 kilograms will be actually even less. So on the other hand, if you stay with 3 kilograms, if you're 20 Newton, the acceleration will be twice as much. 40 Newton with 4 times more. So this is a simple application of the acceleration, second law. And this is the second law again, but remember Newton's second law is an equation with 3 variables. A equals force divided by the acceleration. So in this case, but the acceleration is given, then the book acceleration is given, the mass is given, so mass times acceleration equals the force. So, and number 5 is the same thing. Okay, the net force does the road exist on a bicycle? Okay, what net force does the road exert on a bicycle and the rider to give them a acceleration of this? So you try to find the force. So, and we know the acceleration, we know the mass, so mass times acceleration will give you the force. Hello, here is math for number 3 in previous slides and exercise. 10 Newton of force is proportional to it. You know, the stronger the force, the stronger the acceleration. And then 3 kilograms mass, well, if you divide it by 5 or 6, and the acceleration will be smaller. So force divided by the mass, and then you get 3.3 meters per second squared. So that's Newton's second law in mathematical form. Now, I just created another question. If you have 20 newtons instead of 10, then you simply just put 20, and then of course you will get 6.6, right? And then meter per second. Instead of 20, if you increase from here 6 kilograms, then you will divide it by 10 by 6, and then there will be less acceleration. So that is the number 3. Then number 5 is to try to look for the force, and then this is Newton's second law in the original form. But of course, if you know the mass, multiply both sides by the mass, then you have a force equals mass times acceleration. Then simply multiply the 1.25 with whatever the acceleration, 5 point something meter per second squared, this number times this number, and then you will get the force, something like 1.2 newtons, and so on. Again, here is number 3 and 4, and just because my picture was there, you can see clearly. And 10 divided by 3, so 10 newtons, 3 kilograms, so you get a 3.33 meter per second squared. And number 4, and mass times acceleration is the force. So 1.25 times 5, that's 6.25. Okay, so that's pretty straightforward, newtons. So, and in this equation, there are 3 variables. If you know 2 of them, you can simply solve the third one. So it's simple math manipulation away.